bottom. So what would we do here? Multiply by root 2 over root 2. What would you get on top? 2 root 2. What would you get on the bottom? 2. And what happens to those 2's? They cancel and you just get root 2. Some weird shit, right? Okay, so we have that. I'm going to run out of room. Whatever. This is equal to root 2. Yes? Root 2? Square root of 2. What would secant of 45 degrees be then? Same thing. Secant of 45 degrees, for the same exact reason, it's this one flipped, and then rationalize, you get root 2. And then finally, what's our last trig function for 45 degrees? Yes, cotangent though, right? Cotangent of 45 is the reciprocal of this, and the reciprocal of 1 is 1. There it is. So from here on out, we all have to know those values. All right? We need to know those. All right, let's do a different triangle. Let's do something without 45 degrees, right? But let's still stick to something that I'm going to be able to show you. So let's do a triangle, a right triangle that has an angle of 60 degrees. So what if I draw a triangle? I tell you this is 60 degrees. And I want to know what's sine of 60, what's cosine of 60, what's tangent of 60, what's cosecant of 60, what's secant of 60, what's cotangent of 60, right? I want all 6 for that angle. The problem you run into is that, you know, in the previous one, I could make up the sides myself, right? Like I did the 45, and I could say this is 1 and 1, or we could do it another way, and I could say this is 5, 5 and 5. The reason I could do that is because those angles were the same, right? 45 and 45. Do y'all see here we don't have that property? We do not have the ability to call this something and this something else and say that they're the same. Because this angle is actually what? 30, right? So we are not allowed to use this way. Do y'all see that? So how in the hell are we going to do this? Well, we're going to be clever, all right? Being clever is always fun. What we're going to do, because I don't know what to do with this, is I'm going to just right-click copy my mouse, right-click paste. Okay, so I'm going to make a copy of this. I'm going to flip it over. Here it is. Same triangle drawn like this. Okay? What kind of triangle is this new triangle that I've created, this new one, this big one right here? Do y'all know what we call this triangle? Do you notice in this big triangle, do you notice what all the angles are? This is 60, right? This was 60 because I flipped it over. 60 plus 60 is 120, which means the remaining angle must also be 60, right? Or you could say that, look, this was 30 and 30, right? So this is 60. All the angles in this triangle that I've created are the same, which means all the sides must be the same, right? They must all be the same. So what I'm going to do is now I have freedom. I can do this however I want. So because I know where we're going with this, I'm going to call this side 2, and that makes this side 2, and that makes this side 2. Y'all buy that? I mean, that's fair, right? No one's objecting? So let me just take a step back. What we're doing right now is I'm at the end of the day, I'm gonna need you to memorize these values. I need you to know them, okay? But what I'm doing is trying to show you where they come from, right? Like, how do we get to these results? You don't have to ever prove this again, but in this class, if I can show you where something comes from, I'm going to show it to you. And that's what the book does, the same thing, right? So you're not going to have to reconstruct this, all right, on your own. All right, so you're all right with that? So now I'm going to go back to this picture, okay? I'm going to go back to this picture. And let's just look at the left side again. Maybe now with that, with what I drew up here, maybe you can give me some more details about this picture. This is 60, right? This is 30. And do you know this side? 2, right? Do you know this side? 1. Okay. That's the big thing because it's halfway, right? This is half of this side. So that's got to be a 1 now. And now don't I have 2 sides of a right triangle? Yes? So if I have 2 sides, then I can always get the other one by doing Pythagorean. So I'll call this side B, and then we'll use Pythagorean. I'm going to erase these. A squared plus B squared is C squared. Yeah? I think I'm recording. 1 squared plus B squared is 2 squared. So that means 1 plus B squared is 4, which means B squared is 3, right? Subtract 1 on both sides. Which means B is square root of 3. And now I'm in business. I have all 3 sides. So what is sine of 60 degrees? So here's 60 degrees. Sine is SOHCAHTOA, so opposite over hypotenuse. So what is it? Square root of 3 over 2. Is it okay to leave it like this? Yes, because it's rationalized. The denominator doesn't have a square root. So that's it. Cosine of 60 degrees. Adjacent over hypotenuse. What's adjacent? 1 over 2, right? So 1/2. And then tangent. Okay, so tangent of 60 degrees is going to require a little bit of work, but let's just go over to our triangle. Oh, wait, no, it's not going to require any work, is it? What is it? It's the square root of 3 over 1, isn't it? Which is just square root of 3. Oh, that's not bad at all. Now let's get all the reciprocals of these. So what would cosecant of 60 be? This one's going to be ugly, right? Because I have to flip that one. So 2 over root 3. Y'all know how I remember cosecant's the reciprocal of sine? The s in the middle. That's how I remember it's the reciprocal of sine. I don't know why, that's just the way I remember it. And then secant is just the reciprocal of cosine. By default, it's the other one. I can't leave my answer like that, can I? No, I need to multiply top and bottom by root 3. So if I do that, I get 2 root 3 over 3. That's it. 2 root 3 over 3. How about secant of 60? Just 2, right? That's a nice one. Just flip that one over. And then cotangent 60 is you're going to do, this is like over 1, right? So you flip it. It's 1 over root 3, but we can't leave it like that, right? We have to multiply it by root 3 on top and bottom. So you should get root 3 over 3. Okay. We have all 6 trig functions for 60 degrees, right? So we got all 6 for 45. We've got all 6 for 60 degrees. How about for 30 degrees? I bet you we can get them for the 30 degrees without having to do any work. What is sine of 30 degrees? How are you getting that? Yeah, so 60 and 30 are complementary angles, right? So using what we did over there, sine of 30, right? Sine of 30 is equal to cosine of its complement. So the complement of this is 60, so I go to cosine of 60 and it's a half. So I'm just going to write it down. This is equal to cosine of 60, which is a half. All right. What's cosine of 30 degrees? That's sine of 60, right? And that's root 3 over 2. And then what's tangent of 30? Cotangent of? It's tangent. Cotangent, it's, yeah. Which one, where is it? Top right, right? Tangent of 30 is cotangent of 60, which is root 3 over 3. Do you think you could get the rest of these? Could you get the rest? The next 3? Just flip these over, right? Okay, so I'll stop here. So in the textbook, there we go. In the textbook, the e-book, I should say, there's a table where they give you, so they give you the angle, like look at the top one. The angle here is 30 degrees, or you could say pi over 6 if you're talking about radians, and then it tells you what sine of that is. Is that what we got? What was sine of 30 for us? 1/2? So it's 1/2. Cosine of that angle is root 3 over 2. Tangent of that angle is root 3 over 3, and so on and so forth. So they've given you all 6 of the trig function values for these common angles, 30, 45, and 60. All right? Any questions? All right, I'm gonna ask you to see if you can figure something out then. I would like for you to figure out what find what tangent squared of pi over 6 minus sine squared of pi over 4 is. Right, so it seems like all of a sudden, you know, everything was fine, then I give you something like this. It looks crazy, right? It looks like, whoa, what's going on? So let's make sure we understand the notation. From last class, what does this squared here really mean? What am I squaring? Am I squaring the pi over 6? What is this actually squaring? No? The whole function. It's taking the tangent of pi over 6, whatever that is, and then squaring it, right? I remember in class last time I said, this notation means this. Let me repeat. This notation means this, and I told you 3 times. This notation means this, right? So that's what this notation means, right? This means this. Then I want to subtract from that. This notation means sine of pi over 4, and then squared. Now, pi over 6 is a radian measure, right? You need to know what that is in degrees. So it's one of the common ones that you just drew on your quiz, right? Where was pi over 6? What angle was that? 30 degrees, right? So now, this is really, if you want to put it in degrees, this is the same as saying, what is tangent of 30 degrees? And then squared. Then minus, this is sine of, okay, what's pi over 4? 45 degrees. And then squared. Now we're just learning these, so we don't have these maybe memorized yet. So let's just go to the table. Tangent of 30 degrees. So what is tangent of 30 degrees for us here? Square root of 3 over 3, right? Square root of 3 over 3. So this becomes the square root of 3 over 3, right? But we still have to square it, don't we? So it's tangent of 30, and then we square it. Then minus, what? What's sine of 45? Or sine of root 2 over 2? So this is square root of 2 over 2, but then we still have to square that, right? And so now this becomes, okay, if you square a fraction, you can square the top and bottom, right? So what happens when I square the top? 3, square the bottom, 9. So I get 3 over 9. Yes, I'll reduce that in a second. Minus, square the top and bottom here, we get 2 over 4. Let's reduce the fractions. 1/3 minus 1/2. What's 1/3 minus 1/2? How do y'all do this? How do y'all subtract fractions? Do y'all know the shortcut? Shortcut, you multiply these two together. 2 times 1, 2, and then you say minus, and now you do 3 times 1, 3, and then you put it over 3 times 2, which is 6. And that gives you negative 1 over 6. Your answer is negative 1/6. Your other option is to get a common denominator. So if that's something you want to see and talk about, just come talk to me more about that later. This is more of an algebra thing. Got it? Tangent of pi over 6 squared minus sine of pi over 4 squared equals negative 1/6. This was just purely to see if you understood notation and then how to read this and get it from your table and get your values, and then square them, put them together. Okay, we're about halfway through. Let's move on to the next topic. What if you have this? What if I draw you a triangle, right triangle, but I give you that this angle here is 20 degrees, right? And now I ask you to find all 6 trig function values. So find all 6 trig function values. So first thing I want is, what is sine of 20 degrees? It's cosine of 80, that's right, but what's cosine of 80, right? You don't know what cosine of 80 is.
Cosine of 70.
Oh yeah, 70. Did you say 80?
Yeah,
or
I said 80.
Someone said 70, but we don't know what cosine of 70 is, right? So maybe I can draw a triangle like I did the last one and be clever. Like the last one, I created that equilateral triangle, and then I was kind of, right? And it worked out. It did, right? For 60 degrees, I was able to make it work. Okay, so here's the deal. I don't have a way of doing this. Okay, there is no way of doing this. But what I do know is that if you draw a triangle with an angle here of 20 degrees, it doesn't matter how big that triangle is, right? If we do sine, which is opposite over hypotenuse, for any one of these, we should all get the same answer, shouldn't we? Okay, so fortunately for us, our calculators will tell us what that ratio is right now for us. All right, it will. So if I should have told you all last time, from here on out, make sure that you have your calculators with you. All right, all you need is a scientific calculator, something that can do sine or cosine. Today and today only, I'll let you use your phone if you don't have this, but I want everyone playing today. So please get either your phone or your calculator out, calculator preferred. And what I want to know, let's hit the pause button real quick here. Okay, let's pause this for a second. Let's see if our calculator is correct, if it actually works. So what did we say? I'll come back to that. What did we say sine of 45 degrees was? Square root of 2 over 2, right? Root 2 over 2. So real quick on your calculator, I want you to do square root of 2 over 2. Just do that and tell me what you get. I'm trusting you know how to do square root of 2. Shit, I don't even know how to do square root of 2. What the hell's going on with this thing?
I like the color of your calculator.
Thank you. I don't know where I got it. I've got calculators laying everywhere, so this one's easier for me to not lose because I can find it. Thank you, thank you. All right, so what do you get here? Get a decimal, right? What is it? Approximately 0.707, right? Something like that? Okay, so we've already proven, because I drew a picture, you all agreed, we did it. We all agree that sine of 45 degrees is 0.707. Now, on your calculator, clear that out and find your sine key. And what I want you to do is type in sine of 45. But wait a minute, hold on. Your calculator needs to know that you're feeding it a degree. So your calculator needs to be in degree mode. It's either going to be degrees or radians. Those are the two types of angles we can give it, right? So right now, make sure you're in degree mode. And if you don't know how to get into degree mode, I don't know either unless I look at your calculator. Do you have a question?
Mine isn't giving me the first one. When I put that in.
You typed in square root of 2 and divided by 2 and you didn't get 0.707? Okay, I'll come look. Everyone get in degree mode. When you get in degree mode, I want you to put in sine of 45 degrees, and you better get this answer. Let me see here. If you get this answer, 0.8509, anyone get that answer? Okay, that would mean you're in radian mode. That means you made a mistake, okay? So not this. You need to be getting 0.707. You tried to do square root of 2?
Yeah, I usually have my other calculator.
Oh, okay. Now just take that, just hit times 1, 1.0, times 1.0, and it's going to give you the decimal answer.
Okay.
That calculator will always give you like the very fancy, pretty answer, unless you multiply it times 1.0, then it'll give you the decimal. Okay? Was everyone in here able to confirm on their calculator that sine of 45 degrees is root 2 over 2 or, 0.707? Yes? All right. Just for the sake of doing it, what about tangent of 45? Do tangent of 45. You should get what? You should get 1. Try it. You get 1? Yes? You all right?
Yes.
Okay. It's so awesome, it's like choking you up. Yeah? Okay. So our calculators are built so that they will provide us the ratios for all 6 trig functions for any angle, which is nice, right? So if I wanted to know what sine of this is, that's this opposite side divided by the adjacent side, right? I don't know what they are. I don't know what the opposite side and adjacent side is. But here's what I do know. If you took this side and divided it by this side, if you took that ratio, you would get, sorry, I switched to radian mode. What do you get? 0.342 something? Approximately 0.342. That's the ratio. Yes?
You labeled the hypothesis.
I did do that wrong, didn't I? Thank you. Opposite, this is hypotenuse. Thank you for pointing that out. I have a deeper question. Do you think it's ever possible for an angle between 0 and 90 degrees, do you think it's ever possible for this ratio to be bigger than 1? Can this number ever be bigger than 1? Yes or no? Why not? 1, no. No, think about the ratio. Think about the ratio. This number represents this side divided by this side, right? To say that this answer would ever be 1 or more would mean that this side would have to be bigger than this side, right? Is that possible? No. On a right triangle, the hypotenuse is always the bigger side. So this will always be bigger than that, won't it? Which means that this ratio for sine should always be smaller than 1. That's actually going to turn out to be a property of sine, is that it's never bigger than 1. With me? How about for cosine? What's cosine of 20 degrees? So you need your calculator, right? And there's a key on there, cosine. Cos, cosine. About what? 0.93? 0.93969. I don't know. Rounding the computer, when you do your homework, it'll tell you how many decimals to go to. I'm not real big on the rounding part. Can cosine ever be bigger than 1? No, same reason, right? Because the ratio of this divided by this will always be bigger than the adjacent side. What's tangent of 20 degrees? By the way, this right here, this squiggly equals, if I haven't mentioned already, that is a mathematical symbol. I'm not making that up. It means approximately, right? It's approximately whatever we're getting here. So what do we get? Tangent, 20? 0.36, 0.364, all right? All right. Questions? Yes?
I don't know if I can cut it again, but I'm not getting any of those.
So you're probably in radian mode. So I'll come help you in a minute. What I'd like to do, now I'm not going to do the others. We could get the other 3 answers, couldn't we? How? Like if I wanted, I'll do one of them. If I wanted cosecant of 20 degrees, how would you calculate that? I would do 1 divided by this number. Because it's just the reciprocal of that, right? So this would be approximately 1 divided by 0.342. By the way, there's not a cosecant button on your calculator. You only get these 3. And then if you want the other trig functions, you just do 1 divided by those. All right? So if I want that, do 1 divided by 0.342. And I get approximately 2.924, something like that. Can cosecant, check this out, can cosecant ever be smaller than 1? No. For the same reason, remember cosecant is not, it's a reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. This side's always bigger than this side, so that ratio should always be bigger than 1. So it's like the opposite of what's happening for the sine and cosine. Okay, degree mode. Oh, I wanted y'all to do this. New triangle. Just curious how you're going to handle this. If I give you a triangle like this, and I tell you this angle right here is pi over, no. Pi over 10. That is not one of the angles that you just memorized and put on your quiz, right? The ones that you had were like pi over 6, pi over 3, pi over 4, right? This is the pi over 10. So can you tell me all 6 trig functions? What's sine of pi over 10? Work on that while I help over here with the radian degree. Did you figure it out? No?
I think I did.
You did? Did you get the answers now?
I got the first one. It looks like it's going to fall.
So how are you
off.
switching your mode? You see the mode? There you go. And there you go. Yep, that's it. Who has an idea of how to do this? Like, how would you do it? How would you do it, sir? There's a couple of different ways, so.
I mean, pi is 180 degrees, so couldn't you break it down to 18 degrees?
Okay, so you would convert this angle from radians to degrees. That's one option. Okay, so let me do that way first. So you could say, wait a minute, pi over 10 times, now to convert it to, this is radians, right? Why is it radians? There's no degree symbol up here, right? So pi divided by 10, to convert it to degrees, you multiply by 180 and you divide by pi. That's the conversion to go from radians to degrees. Cancel the pi's, and you get 180 over 10, which is 18 degrees. So this is the same as doing sine of 18 degrees, and you can be on degree mode on your calculator, all right?
Could you also just look it back to radians?
Or you can just switch your calculator to radians, and then type, do y'all have a pi key on your calculator?
Yeah.
Most of you do. Just type in sine of pi over 10. But make sure you're in radian mode. What's the answer you're getting? You should be getting 0.309, something like that. I recommend that you make sure that you can get this answer in both modes on your calculator. Make sure you can get it in degrees and that you can get it in radians. Who has a question? Who needs help? Who wants me to show them how to do something on the...
When it's in radians, so the pi over 10, that's when you would use radians to calculate?
That's right.
Okay.
Yeah, you'll only use degree mode if you see a degree symbol. Watch, y'all want to see a problem that tricks students? Here's a problem that tricks students. When I give them something like this. What is sine of pi over 4 degrees?
That's 45 degrees.
It's not 45 degrees. Because I've given you the angle. This is the angle, right? Isn't pi just a number? Okay. Pi divided by 4 is just a number. That's how many degrees this is. So you would need to be in degree mode to do this problem. Versus if I gave you this, sine of pi over 4. Now, do you see there's no degree symbol here? That means it's radians. And then you could go look at that and you could say sine of pi over 4 would be what? Root 2 over 2? That's square root of 2 over 2. This one, I'm going to have to use my calculator. Let me make sure I'm in degree mode. And sine of pi over 4. In degree mode. Who's getting this one? Who got this one? 0.0137. These mean completely different things, right? Yes?
Is it because you're doing pi as 3.14?
No, it's because I put a degree symbol on this one and I didn't put a degree symbol here. The degree symbol means I'm giving you the angle in degrees, and so you better be in degrees on your calculator. If I don't put a degree symbol, then you're in radians. Look, what about this? What if I asked you what's sine of 5? Are you in degree mode or radian mode? Radian mode. And you're going to get an answer, right? What if I said sine of 5 degrees? Now you're in degree mode. You're going to get two different